Good morning friends, I welcome you all in this session. As you are aware, in previous session we were discussing about probability models in networks, and we have seen how to find probability of a project with a given time. We have also seen that whenever we calculate TE at the last node, at that point the probability of completion of project is 50%. So let us say, for example, if T is 100, so we will say that the probability of completion of project is 100 days. If let us say TS, which is scheduled completion time, or if your client has asked to complete the project in 90 days, then the probability of completion of project will always be less than 50%. Keep this in mind. If client has said that you can take 110 days, then probability of completion would be more than 50%. Now with this information in mind, we will take up one or two more examples on probability, and then we will move on to some other topic. So the problem which we are going to take up today is quite an interesting one, and it is interesting because it has got if you complete a project before time, then client is ready to give you bonus. If you don't complete, then there would be penalty, right? So these two new points would be discussed in today's session. So we will take up an example, and the example is very simple, and in this example there is a project given to you, and actually you are doing a project for a client, and you have said that you would complete the project in 35 days. So this is what you have promised to the client, that you would complete it in 35 days. And the project is like this. It has got several activities. So activity A, you have got A, B, C, D, E, F, G, right? So these are different activities. So this column is activity column, right? Now there is precedence relationship also given. So precedence or preceding activity here is for A is there is no predecessor activity. For B also there is no predecessor activity, right? It means A and B are starting simultaneously, right? For C you have got A. For D you have got B and C. For E you have got A. For F you have got B and C, right? And for G you have got E and F, and for H you have got D, E and F, right? So since you have been given this precedence relationship, you can draw a network. Now after drawing a network, you need to have time estimates. So as far as this particular project is concerned, it's a PERT project or PERT network, right? And you have been given 3 time estimates. So for as far as A is concerned, you have got, let us say, optimistic time, most likely time, and pessimistic time, right? So TO, TM and TP. So optimistic time is 6 at 10, 6, 8 and 10. 10 is the pessimistic time. Then 7, 10, 13. 7, 10 and 13 for activity B, right? For C it is 4, 4, 4, right? This is for C. So this is up to C we have completed, right? Then for D it's 9, 12, 15, 9, 12 and 15. For E it is 5, 6, 7, 5, 6 and 7. For F it is 4, 7, 10, 4, 7 and 10. For G it is 8, 10 and 12. And for H it is 9, 12 and 15. So these are different time estimates, right? So first of all, what you should draw a network of this problem, and the question is, as I said, you have promised to the client that you would be completing this project in 35 days, right? If you complete this project before 35 days, then you will be getting 5% bonus per day. If you don't complete, then there would be a penalty of 8% per day. 8% per day. The company will earn 3 million in total contract price of 10 million. So contract price is 10 million and company will earn 3 million. So determine the expected earning of this particular project. So that's a question. Now first of all, what you should do, you should draw a network for this particular problem, and the network is to be drawn carefully because you need to find out critical path and so on, right? So let us draw a network. So this is first, second, third node, fourth, fifth and sixth, right? So activity A, activity B, activity C, activity D, activity E, activity G, activity H, activity F, and this is a dummy activity. Now if you look at this particular network, you need to write expected value of this activity A, and what we have been given, we have been given 3 time estimates for A, 6, 8 and 10. So how to find out expected duration of this activity? You know, TE is equal to TO plus 4 times most likely plus TP divided by 6, right? Isn't it? This is our formula, right? So for A, what would be the TE value? So if you look at this, this is 6 plus 10, 16 plus 8 into 4, 32, 48, right? 16 plus 32 is 48 divided by 6, you will get 8. So 8 is the duration of activity A. What about activity B? 7, 10 and 13. So 7 plus 13, 20 plus 40, 60 by 6, which is 10, right? Now if you look at activity C, C is this activity, right? This is 4, 4, 4, right? So 4 plus 4, 8, 8 plus 16, 16 plus 8 is 24 by 6 is 4. So this is the duration of activity C. Now if you look at activity D, so 9 plus 15 is 24 plus 48, 24 plus 48, 72, right? 72 by 6, you will get 12, right? So for D it is 12, right? For E you got 5, 6 and 7, 5 plus 7, 12 plus 24, it is 36 by 6, which is 6. So for E it is 6, right? Now for F, it is 4 plus 10, 14 plus 28, it's 42 by 6, it is 7. For activity G, you have got 20 plus 40, 60 by 6, that is 10. For G it is 10. For dummy activity 0, right? For H, 24 plus 40, 8. So in this way what we have done, we have calculated expected time for all these activities. Now if you look at this, these time estimates, intelligently we are getting all T as Tm. So we have chosen these time estimates such that the T is equal to most likely time for all these activities, right? Now what is the critical path? For critical path, let's start calculating TE, right? So TE at this point is 0. At this point it is 8. This point it is 8 plus 4, 12, right? Then 8 plus 6 is 14, 12 plus 7 is 19, right? T at this point would be 24, isn't it? 24 plus 12, 36, right? So if you want, you can get your critical path by even seeing at this forward path itself, right? So we are getting maximum value from here to here, right? Let me use different color pen. So this is 8, this is 12, this is this, and this is this. So this is your critical path, right? Otherwise what you can do, just take TL is equal to 36 and calculate all other TLs, and critical path would be that path where TL minus T is equal to 0, right? But in fact since this is a small network, you can easily find out critical path. In fact there is no need of doing all this T and all those things, right? Just by looking at this network itself, you can see which is the critical path, isn't it? So let me erase all these things, right? Okay. So critical path is known, right? Now since critical path is known, let us find out what is variance along critical path. So our critical path is A, C, D and H is our critical path, right? Now what is the standard deviation along A? Standard deviation of activity A. So let's calculate standard deviation of activity A, right? Standard deviation of activity A is what? It's TP minus TO divided by 6, right? So this is 4 by 6, isn't it? It's 10 minus 6. 10 minus 6 is equal to 4. It is 0.66, isn't it? Now let us look at standard deviation of B. So 13 minus 7, which is 6. 6 by 6 is 1, isn't it? Standard deviation of C is AC. No, this is actually there is any need to find standard deviation of B. You need not require, right? So in fact after A you can directly go on C, isn't it? So standard deviation of C is what? It's 4 minus 4, it's 0, isn't it? Then standard deviation of, we have calculated for this, let us calculate for D. day is this, right? Day is this, right? So 15 minus 9 is 6, 6 by 6 is 1, and standard deviation of h is this, right? So 15 minus 9, again 6, 1. Now let us calculate variance along critical path. So variance along critical path is 0.66 square plus 0 square 0, 1 is okay. Just for simplicity, let me write, right? So this is 1 1 2 2.66, under root of 2.66 is, you need to calculate it, right? I think it is 1.41. Let me give answer to this value. So it is 1.56. It's 1.56, right? So this is variance and this standard deviation along critical path, right? Now if you look at this question carefully, we are saying that we will complete this project in 35 days, right? Isn't it? So 36 days this project is taking, but we have said that we would complete in 35 days, and the probability of completion of this project in 36 days is 50%. If we complete it in 35 days, then we will get a bonus of 5% of this the amount which you are earning, right? Similarly 8% is the penalty. Okay, so let us look at what are different possibilities here. So we will look at this project, and we will consider only those durations which are in plus minus 3 sigma limit. So I know that mean is this, right? So 36 is the mean. So we will complete this project in 36 days, plus minus 3 sigma is this. So is 36 plus 3 into this is approximately 4.5, or let it be 5, right? So this is 5, right? This into this is 5. So 36 plus minus 5, approximately you can take 5, right? So this comes out to be 31 to 41. So we will find out what is the total penalty and bonus for this range of days, right? So what is the probability that project would be completed in 31 days? We will calculate bonus at 31 day, 32nd day, 3rd, 4th and so on, and after 35 you will have penalty, right? So what is the penalty on 36th day, 37th, 38th, 39th, 40th and 41st day, right? So you need to calculate the penalty plus bonus for this particular range of days, right? So let us calculate that penalty, and for this you need to look at Z table. So I'll prepare a table for this. And in this table, first of all, you have got days, right? So you are starting from 31st, 32nd, 33rd, 34th, 35, 36, 37, 38, 39, 40 and 41, right? Now once you have this, now you also know that At 36th day, this is actually 0, Z is 0. Z is 0, it means in other words the probability of completing this project is 50%, right. So 0.5, this is 0.5. So let me write something called cumulative probability here, and then we will write down probability and then penalty oblique bonus, and finally you got what is that amount, right. So first of all calculate all these Z values, all Z values. So this is how to calculate Z value here. How did we calculate this 0? This is Z is equal to x minus mu divided by standard deviation, right. So here x is 36, mu is 36, so Z is 0, right. So for 35th day, what we will have, it's 35 minus 36 divided by 1.56. So this is minus 1 divided by 1.56, and this comes out to be minus 0.64. So minus 0.64, minus 0.64, right. And for 37th day it would be plus 6.64, right, because instead of 35 you would be writing 37. So for 34th day, what would be the value of Z? Just write this 34, this is minus 2, and you will get value minus 1.28. Similarly, for 33rd day, just change this to 33, this is 3, and the answer would be minus 1.92. For 32nd day, change this value, this would be minus 4, and the answer would be minus 2.56. and for 31st day, this is 1, this is 5, and the answer would be minus 3.20, right. So whatever we have calculated for Z values for these days, we will calculate Z values for these days also. Only there would be one change of sign, right. So this would be 1.28, 1.92, 2.56 and 3.20. So what we will say that the probability of completing this project, the cumulative probability of completing this project at this is 0, right, because it's more than it is beyond 3 sigma limit, and in fact you can take this value as 1, right. So probability of completing project in 41 days is 100%, right. Here it is 0, it is 1, and this is 50%, right. Now what is the probability or cumulative probability for completing this project on 35th day? How would you do that? For this you need to look at Z table very carefully, and as I said, probability of completing project is 50% here, and that probability will come down will go down in this direction and it would be 0. It means whatever is the area under curve, right, 0.64 value of z in table, subtract that value from 0.5, okay, and then just write those values here. So let me do it for you. So for 0.64, look at z table, right. If you look at z table, it's there. In fact, I will show you where is z table. So z table is here, it's 0.64, right. So 0.6 and 4 is here, right. So 0.2389. So value of z, area under curve at 0.64 is what? We have just checked, right. It is 0.2389. So 0.5, let me do this calculation here. So 0.5 minus 0.2389 is equal to 0.2608. Right. So what we have done here, we calculated area under curve at 0.64, we subtracted it from 0.5, right. So probability of completing project in 35 days is 26%. Similarly for all other values. At 1.28, what is the area under curve? 1.28. Just look at this table, 1.2 and 8, it's here. It's 0.3997. So 0.5 minus 0.3997, it is 0.0988, right. Then for 1.92, just check area under curve at 1.92, subtract it from 0.5, you will get 0.0272. Similarly for 32nd day, it is 0.0052, right. Now probability that the project would be completed in 32 days is just it's even 0.05, right. Probability of completing project in 34 days is just 9.88%, right. So 9.88, 2.72, and it's 0.5, it's 0.05, right. Now what would be the probabilities in this direction? It would be more than 0.5, right. So 0.64, look at z value in table and add in 0.5. So 0.64, just look at 0.64 here, 0.6 and 4 is 2389. So you just add 2389. So 0.5 plus 2389, right. So it would be 0.7389, right, and so on. So let me write these values, 0.7389, then 0.9002, 0.9728, 0.9948, right. Now once you are done with this, what you should do, you should calculate probabilities, right. So it's very simple. Since you know cumulative probability, you can calculate probability value very easily, right. So let's say probability is 0, cumulative probability is this, right. So this minus this is equal to this, right? So 0.0052 here also, right? Now this minus this is equal to, you will get probability here, right? So in this way you can write down all the probabilities. Let me repeat, this minus this would be this probability, right? So let me write these values. It's 0.002, it's 0.022, right? Then it's 0.161, then 0.2392, then so this is first, second, third, fourth, right? Okay, so this is 0.7, no, just a minute. So this minus this is 0.002, is 0.0726, then 0.161, then 0.2392, for this is 0.2392, right? This minus this 0.2392, then 0.161, 0.0726, 0.022 and 0.0052. So if you see this, these two values are same, and again these two values are same, these two values are same, these two values are same, and these two values are same, right? Now I know that there is a penalty of 8% per day if I delay the project. If I complete before 35 days, there would be a bonus, right? So let us write down what is the penalty and what is the bonus, right? So let me write over here, it's penalty oblique bonus, and this is amount. So penalty oblique bonus is on 35th day 0, right? Because you have promised 35 days to the client. Anything above this, there would be a bonus of 5% per day. So this 5% on 34th day, 10%, then 15% and 20%. In fact, on 31st day, so this 34th, 33rd, 32nd and 31st. So let me write it here. First 15, then 10% and 5%, and this is 0. Similarly, what would be the bonus penalty is 8% per day, right? So this 8%. On 36th day, this 16%, 24%, 30%, this 32%, right? On 39th day, 40% and 48%. Now since you know what is the probability of completion of this project, and you also know the penalty and bonus in terms of percentage, just keep in mind all these are in percentage, right? So you need to multiply probability with your penalty or bonus. So this is 0, this is 0.0052 into 0.15, because this is percentage. So let me write it here, so this is the column. So what we are doing, this is 0.0052 into 0.15, this is equal to 0.0078, 0.00078. This is your okay. So since a lot of calculations are to be done in this question, let me stop here as far as this particular session is concerned. We will have remaining part of this question in next session. Thank you very much.